Welcome, everyone, to another Dynamic Explainer. Today, we're putting on our detective hats and acting as investigators to crack the secret code of an actual invisible superpower. Seriously, it's a phenomenon that has fascinated scientists and explorers for centuries, and is happening right in front of us, literally every single day. We are, of course, talking about magnetism. I want you to start by asking yourself a question. Picture an invisible force that can physically move a solid piece of metal across a table, completely without touching it. I mean, it kind of sounds like magic, doesn't it? What could it possibly be? Well, before we officially reveal the target of our investigation today, keep that invisible pulling force in the back of your mind because we're going to break down exactly how it works. Here is our investigation roadmap for this explainer. First, we'll start by uncovering the force itself. Then, we're discovering the poles, followed by learning the strict rules of attraction. After that, we're going to scale things way up to look at navigating with giant magnets. And finally, we'll wrap up with the crucial rules of magnet care. We've got some really cool experiments and concepts to tackle, so let's jump right in. Section 1. Uncovering the force. Let's look at their magnetic properties. So magnets don't just come in one standard shape. They actually take on a bunch of different forms, like the classic straight bar magnet, the curved U-shaped magnet, and the circular ring magnet. But regardless of their shape, they all pack that exact same invisible pulling force. Now think about everyday items, things like a wooden pencil, an iron screw, a plastic ruler. Actually, let's throw a brass key in there too. If you were holding one of these magnets right now, I want you to predict which of those items do you think would actually stick to it. Well, let's look at the results. The absolutely crucial point here is that this invisible force does not work on everything. It basically divides the world into two distinct camps. On one side, we've got magnetic materials. These are specific metals like iron, nickel, and cobalt that will aggressively pull toward the magnet. On the other side, non-magnetic materials. Things like wood, rubber, plastic, and glass will just sit there completely unaffected by the magnet's power. It's a very exclusive superpower for sure. Moving on to Section 2, Discovering the Poles. Let's start finding those hotspots. If you actually test a magnet, you'll quickly realize the force isn't just spread equally all over the place. The magic happens at the poles. These are the specific ends of a magnet where the magnetic power, or the pole, is the absolute highest. And here is a totally fascinating rule of nature. Every single magnet, no matter its shape or size, has exactly two poles, a north pole and a south pole. You literally cannot have one without the other. Check this out. When you sprinkle tiny pieces of iron, we call them iron filings, over a bar magnet, they don't just stick evenly across the middle. Nope, they bunch up heavily right at the two ends. This is brilliant visual proof showing us, rather than just telling us, that those ends, the north and south poles, are the absolute magnetic hotspots. All right, Section 3, Rules of Attraction. It's all about like versus unlike poles. Magnets are incredibly particular about how they greet one another. There is a golden rule you got to remember here. Unlike poles will strongly attract each other. That means if you bring a north pole near a south pole, boom, they snap together. But if you try to bring like poles together, say a north pole to a north pole or a south pole to a south pole, they will completely repel each other. They will aggressively push away, and you can physically feel that invisible force field resisting your hands. It's wild. And because of that exact rule of repulsion we just talked about, a ring magnet can literally float in mid-air. If you place a magnet on a stand so that its identical pole, like a north facing a north, is pointing directly at the magnet beneath it, the invisible pushing force is so incredibly strong that it completely overcomes gravity. It makes a solid, heavy piece of metal levitate right there on the wooden stand. On to Section 4, Navigating with Giant Magnets. Let's see how this force helps explorers navigate the globe. Okay, imagine this really cool experiment. If you tie a piece of thread around a bar magnet and hang it freely from a stand so it can spin around without hitting anything, something amazing happens. No matter how much you spin it, when it finally comes to rest, its north pole will always magically point toward the geographic north direction every single time. So you might be wondering, why does a hanging magnet always point north? It is definitely not a coincidence. The awe-inspiring fact is that our home planet Earth actually behaves like a massive, giant magnet itself. Deep inside the Earth, swirling liquid metals create a massive magnetic field that wraps around the entire globe. That giant magnetic field is reaching out and pulling on our little suspended bar magnet, forcing it to align perfectly. This knowledge allowed humans to create a completely world-changing tool, the magnetic compass. A compass is essentially just a miniature version of that hanging bar magnet we just talked about. The tiny spinning needle inside the glass case? It's just a small, lightweight magnet. Because it can rotate freely on a pin, it constantly aligns itself with Earth's giant magnetic field, safely pointing explorers, sailors, and hikers toward the north. Finally, Section 5, Magnet Care. Here is how to keep our magnets strong. We really need to go through this crucial checklist of what not to do. Because yes, magnets can actually lose their superpower. It's a process called demagnetism. If you heat a magnet over a flame, if you hammer it or strike it hard against a surface, or if you repeatedly drop it from a tall height, you will jumble up its internal structure and completely destroy its magnetic field. Even just tossing them in a drawer without storing them properly can weaken them over time. So handle your magnets with care. You don't want to break the invisible magic. To wrap up, I want to leave you with one final, thought-provoking question to test your inner investigator. Suppose you have a bar magnet, and you decide you only want a north pole. You take a saw and break that magnet perfectly in half. What do you think happens? Do you get one piece that is entirely north and one that is entirely south? Amazingly, no. You simply end up with two brand new, smaller magnets, each with their very own north and south poles. But why? Why can't a north pole ever exist on its own? Well, that is a deep physics mystery I leave for you to investigate next. Keep observing, keep questioning, and keep learning.